Hello everyone, and welcome to my first video on the design of realistic spaceships. This is for general purposes, not just for people playing Kerbal Space Program, which I make a lot of videos on. And so it is for people in a 3D environment like Blender, trying to design something for artwork or for a game or something like that. And the goal is to have the prettiness, the nice design, also have functionality. There's a purpose behind it. It makes sense. Somebody who is knowledgeable about space things isn't going to look at it and furrow their brows and wonder what the heck is going on. So there is a logic to it, and with this logic, we begin with crew. If you have crew, of course. If it's an uncrewed vessel, it's a lot easier, and then we'll talk about, the cargo and stuff like that. But if we have crew, we need to begin with crew, because people are squishy, and they have requirements. They need some space, they need to be oriented a certain way, and we need to take that into account first and get the volume for them set up in the right place, have windows if necessary, and then we can lay out everything else, because the volume for the people is going to determine a lot of other things. And so we have here a seat and an engine. And that is because the orientation of people in relation to the engines is very important. Here we have the typical launch configuration from Earth. Now, if your vessel is not going to be launching from Earth, it doesn't need to be like this. But if your vessel is launching from Earth or is going to be expected to have a thrust-weight ratio greater than 1, that means an acceleration greater than 9.8 meters per second squared, greater than gravity. Then we need it oriented more like this, because otherwise the blood is going to rush to the feet or to the head, and the people are going to black out, they're going to red out, and that's going to be a problem. So, or you could have a sci-fi device where, they take a pill or something, like in The Expanse, they have some special method to deal with high thrust-weight ratios, but they're still oriented like this, actually. The engines are still in the back of the spaceship, and from the camera view, they aren't visually laying on their backs, but they're actually in this orientation compared to the engines in The Expanse. So, but they still, because the thrust-weight ratio is so high, greater than 4. If it's greater than 4, you need something special, because 4 is the limit for actually manipulating controls. So in The Expanse, they have very high thrust-weight ratios, so they have all sorts of fancy business in order to deal with that. We're not going to worry about that right now. That's not to do with the design of spaceships. You have to come up with your own sci-fi way of dealing with that. So if the thrust-weight ratio, if the acceleration is greater than gravity, you are going to Earth's gravity, not any other gravity, because our bodies are made for Earth's gravity. Then you need it oriented like this so that the blood doesn't go in the wrong place. However, you don't need it like this if it's thrust-weight ratio of 1 or down to lunar, basically 0.2 or 0.1. If you're just landing on the moon, landing on Mars, landing on one of the moons of Jupiter or Saturn, any of those places, you don't need it like this, and it's fine to have it like this. And better, if the thrust-weight ratio is between 0.1 and 1, let's say, then the people could stand on the floor and operate like that and walk around normally, especially if the thrust is going to be continuous. On the other hand, if the thrust is just for a little while and then it cuts out, they're going to be floating. And we would still want all the things in the room oriented for when the engines operate, because otherwise things will fall into the wrong place, and things will get messed up. So we have to worry about when the engines fire, even when they're not firing. Even if we're in microgravity and people are floating around and doing things like that, eventually the engines are going to have to fire, and you have to worry about that. We'll talk about RCS thrusters and smaller thrusters in a sec. So this is the orientation for thrust-weight ratio 0.1 to 1. And so when you see Apollo landing on the moon, they're actually standing. They're standing in relation to the engine. They're in this orientation, head up in relation to the engines pointing down. as opposed to on their backs. So that's one orientation, but there's a much more complicated situation. The complicated situation is when you've got artificial gravity and you're spinning something. In this situation, the people are standing on the outside. So if this whole thing is rotating for artificial gravity, let me see if I can make an indication of this. So it's rotating like this. When it rotates like this to generate artificial gravity, then the people are standing on the outside surface, not on this side, but inside on that surface, that far surface, the big circle, if you will. So they're standing like that, but because of the rotation at a certain rate, they're going to actually be pushed outward, so they can stand on that surface. But then, this is fine for a station if it's not doing anything else, it's rotating like that. But if you then add an engine into the mix, then you need to worry about how things are going to get pushed again. It can't be a very powerful engine, unless you have some sort of inertial damper or some sci-fi thing but we're talking about realistic spaceships. If you got the engine there, it can't be too powerful that it's going to throw people up against the sidewalls, right? So, or all the other stuff like the food, whatever they're working on, the experiments, they're not going to all get slammed into the sidewalls. So, but that's fine for a low thrust ship. And there are plenty of low thrust options like ion engines and stuff like that, where the thrust-weight ratio is going to be way less than 0.1. And those take weeks and months to do their burns. And so that'll be constant. The artificial gravity to let people stand and work normally will be generated by the rotation. And your little engine is going to do its job while they're doing that, and they won't even notice that it's working. So that's the artificial gravity version. Everybody's got to be standing on the outside. And then, if necessary, if you've got bigger engines, then they would probably come into the center and have seats in the center, and those seats would be oriented however they need to be. Maybe in launch configuration or something like that. This ring, incidentally, actually packs up. So, like that. So you could think of something like that for your own system in terms of how to deploy this, or like in 2001: A Space Odyssey, this sort of artificial gravity ring could be deployed in pieces, which is how it is there. So that is another orientation. That's the artificial gravity orientation, but it limits the size of your engines while that thing is generating gravity, because otherwise they'll be thrown off to the side. So those are three orientations. There might be something else clever, but basically that's the first thing you need to think about is how they're seated, because let's say you have something that launches from Earth, but also has the engines working at some other times, or launching from Earth, but you need them to then go into an artificial gravity ring or something like that. So there's a lot of situations where you're going to have one part of the ship oriented one way for launch, and then another part of the ship oriented a different way for them to be living in. And I generally do this because there's going to be a launch cabin that's also going to allow them to escape during launch, but then they will move into a different part of the ship for most of the journey. So there's that kind of thing to think about. Okay, so that's orientation, and there's probably some other considerations I haven't thought of. If you have some questions or something like that, I can try to answer them. But here it's just a matter of how powerful your engines are, and where they're pointed, of course. To maneuver in space, we'll talk more about this later in a different video. There's RCS thrusters. Generally, those are not powerful enough to throw things off. Like the space shuttle had RCS thrusters and everything. They'll gently move things off to one side, but it's not too much of an inconvenience. So those aren't powerful enough to cause problems, and you don't need to worry about people having to brace for those. Okay, now the next thing we need to talk about is how much space people need. And a lot of spaceships designs seem to not give them enough space. Now, the general rule is that the minimum is 25 meters cubed per person. And that means a cube 3 by 3 by 3, that's 27 really. But let's take a look at the size of it. It's not that big. Okay, it's about the size of a small room. It's a very small, it's like a working cubicle. This seat is actually fairly large. It's for a large person. But you could, you could have a computer system here, and then here, let's have it off to the side. You can have a computer desk and maybe a bed. And then that's it. So that's your 27 meters cubed. And that's the minimum. However, it should be noted that unlike on Earth, if you've got them floating around in microgravity, they can make use of the ceiling space a lot more. And then this cube doesn't feel quite so cramped. So that's the minimum. But on the International Space Station, the amount that they actually have is about 64 meters cubed per person. That's assuming that there are 6 people on board. And so that's the volume they have, but of course it has other equipment and stuff like that. So functionally speaking, it's not like this is all private space and they have this amount of room all on their own. But if you take the habitable volume of the International Space Station and divide it by the normal number of occupants, which is 6, this is how much you get. And that's a very healthy amount. You could conceivably split the 4 meters into 2 floors, but those would be really low ceilings. But especially if they can float around, you can make use of it. But that is a lot of buts. You do have to consider that if you're generating artificial gravity, then that's going to be, you're not going to be able to let them use all of that volume, right? So the ceiling will probably have to be back down to 3. The minimum ceiling is about 2.7. So that's the minimum you can have. And then we have to figure out, okay, how do I get my 64 meters cubed per person? Well, if you have Blender, there is a... it doesn't really capture the preferences window, but in add-ons, there is an add-on called 3D Print. It's Mesh:3D Print Toolbox. And if you activate Mesh:3D Print Toolbox, you will get this menu here. And then for any mesh, you can click Volume, and it'll tell you the volume. So you can figure out exactly how big to make your area for each person. Of course, you'll probably just have one module, and so you'll make a big thing and then just divide the volume by how many people there are. And it might be a cylinder or something like that. It can calculate any volume. So you can use that as a reference for if you have enough space for your people. But take a look at the seat. This is 64 meters cubed. Think carefully about whether you would be comfortable in a room like this. And whether that would be enough for you. And please be kind to your space travelers. So a lot of things seem to not give them enough room, and that worries me. This all came about incidentally because somebody had sent me a image of, or a set of images of a spaceship design. And it was a very large spaceship, mainly based on using the rockets in a certain way. So you would be using a wet workshop. Wet workshop is when you take the rocket body and you're converting it into habitable space. So this was a whole complicated thing and fancy, but it wasn't, there are a lot of things that were not clear to me, like where people were, how they would, and one additional aspect of this is that you generally want the people in your spaceship to be able to reach each other. And that was not the thing in this spaceship. They would all be spread out in different locations, unable to get to each other. So that is an important factor. You want your crew modules to be contiguous. Connected living space is a mod for Kerbal Space Program, and that is an important idea. We don't want two separate communities of people in our ship. So you can have a large module like this. Okay, and then if we take the volume, well, that's basically enough volume for 100 people. Now, how big is that? Well, it's 16 meters. I mean, let's round it off. We could cut it down a little bit, but now let's say 32. That is too big to be launched currently, but if we modify it a little bit, how much is this? Well, that's about 50 people. So this is enough for 50 people, and this is about the size of the first stage of SLS. And actually, the first stage of SLS, Space Launch System by NASA, is 8.4 by 8.4. If we were talking about the external tank of the space shuttle, then maybe we'd go with 50. That there's a tapered end to it. So this is more like the space shuttle. And in the Mars trilogy by Kim Stanley Robinson, that the Mars ship is built out of the external tanks. So they actually took the external tanks, used the wet workshop idea. So we used to be a stage, but now they're turning it into spaceships. And so they took the external tanks and turned them into habitats, and you can see it could be a very large habitat with plenty of room. And then some of the other tanks were used for fuel. So these are some basic ideas. We'll talk more about how I'll create a crew module, or I'll use one of the ones that I've already created for another spaceship, and then we'll talk more about how to lay out the rest of the ship in future videos. But this is just how to deal with crew on your spaceship, and the basics are orientation of the crew. This usually comes up because people are pointing out that in Star Trek, the people are not oriented the right way compared to the engines. And then, of course, Star Trek has the inertial dampers and stuff like that to help out, or whatever system they have to make sure that all the people aren't slammed every time the warp engines come online. So, or the impulse engines for that matter, any engines. So that's when it comes out, and so that's when this topic comes up, and so we need to have the people oriented properly. We need to give them enough space, and then we can see what we can do from there. So if this is of any interest, make sure to press like, and with that I'll say thank you for watching, and I'll see you next time.